Okay, today we're going to do a video on standard variance and standard deviation of samples and populations. Because I understand there's a little confusion, want to make sure everybody understands this before we move on. All right, so we have a data set. My data set is 1, 3, 5, 4, 3, 2, 3, 7. So we're going to put the data in here. Put it in our spreadsheet. And I'm going to do 2, 3, 3, 4, 5. How many threes out? 3 threes, sorry. 3 threes, 4, 5, and 7. The data does not need to be ordered to figure out the standard deviation and the variance. You just need put the data in the first column. Now we have to add it all up. So I'm going to use a calculator, all right? Can't see it, but I have one. So I'm going to do 1 plus 2 plus 3 plus 3 plus 3 plus 4 plus 5 plus 7. And my total is 28. So down here is 28. Now if I wanted my average, it's going to be my total, 28, divided by how many there are. And there's 1, 2, 3, 4, 5, 6, 7, 8. So n is 8. I'm going to once again use my calculator. I'm going to do everything to 2 decimal places. So I set my calculator on 2 decimal places. And my mean is 3.50. So that's my X bar of my sample. X bar sample, mu is population mean. All right, so now what I have to do is I have to figure out my deviations. So I'm going to do 1 minus my 3.50 equals, all right, so 1 minus 3.5 is negative 2.5. And this is 2 minus 3.5, and it equals negative 1.5. Oops, point. All right. And this one is negative 0.5. This one's negative 0.5. This one's also negative 0.5. Now 4, so this is 4 minus 3.5 equals 0.5. This is 1.5. And this is 7 minus 3.5 equals 3.5. Okay? So those are all my deviations. Now I have to square them. So negative 2.5 squared is 6.25. 6.25. Oops. So what we did here is we took our deviation, which was negative 2.5, and we squared it. I'll show you what's going on. We squared it. We took our difference, and we're squaring them. So now I'm going to take my negative 1.5 and I'm going to square it. And this is 2.25. Oops, keep doing that. Now I'm going to take my negative 0.5 and square it. And I get 0.25. This is 0.25, 0.25. And this is 0.25. And this is 2.25. And 3.5 squared is 12.25. Now I need to add these all up. All right? So I got to add this whole column up. Be very careful. 6.25 plus 2.25 plus 1, 2, 3, 4 quarters. So that's a 1. All right? 0.25 plus 0.25 plus 0.25 plus 0.25 is 1. So I'm going to just add 1. Plus my 2.25 plus my 12.25 for a grand total of 24. I got 24.00. Oops. 00. That's my sum of my squares. Now, you had a formula sheet. So the variance, I'm going to go over and look at the formula sheet. Change my windows. So sample variance is s squared, which equals the sum of my squares divided by n minus 1. In this case, n was 8. So I'm going to divide that 28 by 7. All right, let's go back over. So this is s squared. Just get rid of all this, all right? It's going to be s squared equals the sum of all that, which is 28, divided by n minus 1. I have 8. 8 minus 1, so this is going to be 7. So 28, sorry, this was 24. 24, sorry. 24, so 24 divided by 7 is 3.43. That is my variance. 3.43 is my variance. The standard deviation is S, which is equal to the square root of 3.43. So I'm going to take, in my calculator, I'm going to do second square root, 3.43, and my standard deviation is 1.85. All right. Now I'm going to go look at my formula sheet for the sample coefficient. Formula sheet. Coefficient of variance is S, which is my 1.85, divided by my average, then times 100. So this is going to be my 1.85 divided by my mu, which is 3.5, or my x bar, excuse me, times 100. All right, we're going to see what that equals. So 1.85 divided by 3.5 equals times 100. And my coefficient is 52.86. All right, so now we're going to do the same thing, except for we're going to make this population. Take all this, Now we're going to take our data. Let's take our data. And we're going to do this for population. So if this was population, this guy here, this guy right here, he would be, where is mu? Mu. All right? So this guy would be mu. This guy would be mu. Once again, this would be mu. This would be sigma. All right, this would be sigma. Okay. Now, the difference with this guy is going to be the sum of the squares, which is x minus mu squared, which is 24, but it's not divided by n minus 1. It's just divided by capital N. So let's go over and look at the formula so you can see that. Notice, sigma squared, which is variance, is the sum of the squares over n. So we're going to be dividing by 8 this time. And while we're here, we're just going to show you that sigma is the square root of sigma squared, and our coefficient of variance is sigma divided by mu. Let's go back to the example. All right, so now this is not sample, this is population. This is population. And same thing, this is population. Because we're dealing with mu now. And this one is the sum of the squares divided by capital N, which in this case is 24 divided not by 7, but by 8. All right? So 24 divided by 8 is 3. 3.00. And then the square root of 3, because we want our standard deviation, is 1.73. Okay. So now this is sigma. Sigma, which is the standard deviation, divided by mu, which is still 3.5, is a different number. So we got divided by 3.5 times 100. So our coefficient is 49.49. I hope this small demonstration example helps clarify how to come up with the variance, standard deviation, and coefficient of variance for a given data set. And you have to use a table like this manually, like I did with a calculator, or you can use the power of Excel to do all this math for you.